Hello, everyone. My name is Professor Victor Cheng, or you can pronounce as Chang. I'm very honored to give a keynote for this topic, the futuristic AI-based data science and analytics with examples. So in this talk, I'm going to go through with a different example and my research contribution for different um, disciplines. So I'm going to go through with overview as follow. I'm going to discuss about the big data analytics, AI, and related technology overview and architecture, followed by challenges and recommendation. Of course, every example will be much easier to demonstrate to you so you understand the meanings behind, and I'm going to justify and sum up with research contribution, discussion, and conclusion. First of all, we talk about the technological overview. Sensors can be everywhere. As you can see that there are different sensors get connected to collect lots of data, analyze data, and then interpret the implication and analysis. And you know that there are different types of data in different kinds and forms. And of course, being available in different disciplines. And we can then get through the deep analysis without spending much time and cost. And AI, the smart algorithm behind can calculate the best possible ways, understand the meanings, and extract the knowledge and insight from data, combining fields such as statistics, machine learning, data mining, and big data together with cloud computing and predictive analytics. So there are some examples here. You can see that the typhoons can be simulated through the different types of technology. We can then see how the formation, the data of the typhoons and the destructions they may bring it. And as you know, now we have lots of smartphones that get connected to different types of services through apps, and it allows us to get different type of requests to be done on time. At the same time, we can get to all different services without we going to the places physically. And it can all be done similar and related technology will be going through. Sensors and smart devices together with 4G and 5G that works well with smartphones. We then can focus on the data science for everyday uses, for instance, on the weather studies, geoeconomics, and at the same time, we can look at how we can apply this area to GIS, medical, transportation, business and government, and so on. And in order to know data science very well, we have to know how we can maximize the data collection, extraction, processing, and analysis. Together, we have some smarter way to present the results, such as the visualization, analytics, and services. We then have to study on algorithms, the AI, machine learning, and different pattern studies behind it. Then as a data scientist, we also need to know how to have to reduce Spark data lake and other things. And we have to take care of the security and privacy with data trust. So in this example, we can see different types of data can be transferred, and we have databases to collect and understand all different types of data. And then we can then get all the Internet of Things outputs, such as the different types of data into the local networks. And through that, we then can get the data from our client. And in this example, we can see different types of houses. The red ones means the most expensive. The blue indicates the those with low income and middle class are in orange colors. They are in different parts of London. So data visualization allows us to understand the patterns and meaning in just a matter of seconds. So in order to understand different data, we have to study architecture well. So for those people who focus on security, we then can follow this structure, data intelligence followed by distributed systems, and then together with the computing and communication identification. So all the architecture has been followed with the security, and there are 3 layers, such as the energy harvesting, the network protocols, and the data representation. So it allows us to know. Then with the architecture overview, another type is that we divide different classifications based on the domains. So for instance, if you analyze data of transportation, you can then look at the logistic assisted driving, mobile ticketing, and so on. If you are going to focus on healthcare, you may then look at the tracking, the identification, authentication, data collection, and as well as the smart environments. We can look at the comfortable homes, offices, industrial plants, and so on. Personal and social uses can be divided into these four groups, and futuristic, for instance, the robot taxi, the city information model, and so on. So we can then focus on the discipline, and then based on that, we then go into each subcategories. And now, well, I'm going to go through with different examples. For instance, for the healthcare and health informatics as a service, in this example, we can see that this is the for computing with 3 different layers: a device layer, fog layer, and a cloud layer. So on the hospital, we have a device layer with different sensors. They collect data of different types from patients, from the the places the patients live, and even within the hospital, a large volume of data, and all the fog node will be able to collect and transfer data between the client and server side. And on the cloud layer, that allows the scientists, the medical researchers, to get through to the data they need. So each person will have different types of accessibility. It allows them to access different type of data differently. And in this example, because we know that in medical data, there are a lot of algorithms behind, and of course, we need some smarter ways to analyze. So the example behind this will be based on a p-merge, p-map, and p-reduce. So there are 3 different functions that focus on that. So in p-merge and p-map, the focus is to get different data that can congregate into the output. So it's very similar to the map function for the map reduce. For reduce, p-reduce is very similar to reduce function. The difference is that it can handle more at the same time. So it can, instead of just dealing with 1, it can deal with 4 different ongoing or parallel tasks. So in a way that it maximizes the outputs. Then there's another data fusion as different nodes that can get together. So because that's also important for us to get different types of information and congregate them into one. So there are 2 different functions. One is on P fusion to fuse all different parts together. The other one is the M fusion and M update all the data at once. So then this allows us to get into different function. P query is to allow us to perform the execution of queries at the same time. So why is it important? Because when we have done that, we then can use this example. This is the blood clock. It means that when your hands get the cards, this is happening within milliseconds. So you can see that in the yellow, the yellow means in your body, there are different types of smaller molecules or proteins. So there are some team leaders in a way that they congregate all different proteins all together. So when your body is in the risk of losing our immunity or losing blood, so the first reaction is to get all the smaller molecules together. So then under the emergency conditions, all different parts of the molecule get together. So blood clot simulation will be possible through the use of our services. And then this is done behind the scene with a fusion algorithm. So imagine each molecule is having the merge reduce function. And then after that, we have to fuse them together. So fusion algorithm is very powerful to fuse all different molecules together. So that can be done with a computer simulation. Then with the tumor modeling, that's another aspect because cancer can be in different types, and we have to know the malignant tumor which can be coming cancer. So that with a mathematical formula, especially with the exponential growth rate and so on, then we can then simulate different types of tumor and to let the scientists understand. So through the visualization analytics, we can understand how a tumor can be developed, and perhaps that will help the scientists to develop effective treatment. So similarly, tumor can be enlarged and then look at under the magnifying scale. So in this case, this is a fully mature tumor. it means that it's in a very strong shape. However, there are some other areas of weak attack. So in order to make a tumor to disappear, most of people will just undergo surgery to remove everything together. But there can be some biological ways to shrink it. So to identify the weaker spot, like those, purple, blue region, and then shrink it. And COVID-19, has posed one of the greatest challenges that human being have faced. And as you know, we need some novel and intelligent way to analyze the data. So then we can then analyze the patient's data of different symptoms, and then we then have some smart algorithm to identify. There can be some other areas that will need the scientists or the medical doctor to pay more attention, and we can then run different analysis and algorithm to see, which algorithm can be allowing us to identify. Because the thing is, COVID-19, sometimes those with a very minor symptom, it will be very hard to track or differentiate the differences between a flu or COVID-19, or whether those without a symptom. We need some smart way to identify that. So our contribution will allow us to use the algorithms and optimizations together to offer a better analysis of image segmentation, especially with patients with chest X-ray images. So the next one is business intelligence service. We would like to emphasize that our work can offer a very effective way to look at. For instance, we look at the stock market. We can then compute different prices of 6 selected stock at the same time with a time series. Then we can then look at the volatility of asset. Volatility is referred as the market risk. So market risk may vary between different markets and different countries. At the same time, we can then use this. This is the trend of the stock movement, and when we can capture as the overall movement, because there can be a very detailed ups and down, we can then capture that as a movement when the time goes on. And this is a volume. The trading volume may also sometimes be having the correlation with the stock movement. Sometimes a huge volume may mean that there can be some activity of huge sell or buy. And this means the data visualization for risk. For instance, risk is very hard to be quantified, and it varies between different countries and different disciplines. So in that aspect, we then can use this example when a new rule has been in place. For instance, there is a no tax for first-time buyer. At the very beginning, people who take the risk, they will enjoy, a low implied volatility. Then when there are more and more people, there are more competition, more restriction, and of course, there can be harder one. And close to the end of the new campaign, because there can be less people, and maybe the service provider will offer something better. So in a way, the risk or implied volatility may be lower. But at the same time, we can use the same business intelligence service to compute the stock market movement and the trading volume, the R-square value, simplified plot. So R-square value is the market risk in this case. So it will take into the consideration of the movement and trading volume and the market volatility. A simplified plot means that it takes consideration of it. So it can be some ups and downs when it's going down. So in a way that taking the volume and the risk is on the way down. So this is a simplified plot that takes consideration of everything. So then we can have a better way to track the movement, because this is called Bollinger Band. It can be used in 2 ways. One is to use before, or the other one is used after. To be used before means that before the stock moves, you can predict the movement about 15 or 30 minutes ahead. So by reading through the data, then you capture a trend and you make the predictive movement. Then this is the 95% confidence interval with the upper and lower limit. Then you can track before and after the differences. The other one is to use that behind, which means that you let the movement go through at once, and then you then capture the trend of the movement. So with the upper and lower limits. So at the same time, we can use a simplified plot, as I explained earlier. At the same time, we can use this example to analyze stock of different markets, and we can then look at the Commonwealth Bank of Australia and the Boeing, and together with the trading volume and the R-square value, and then we can also compute the business performance in 3D. This is done in a way that, because you may know, in stock market or in any economic activity, there are two forces. One is to buy, one is to sell. So every day they are in a battle, so there can be ups and downs. So the red region indicates that some buffer zone. Buffer zone means area of uncertainty. It means that there are two forces there, fighting with each other. And then there is one. A greater region means that it's going to be affected more. It means that there is an area of uncertainty with a greater percentages that they can be going either way. So therefore, when there is a very clear or very huge red region, means that the area of uncertainty are going up. That means that it's giving the warning something quite undesirable may be happening next. So in a way that it gives warning. So you may notice that there's a likely correlation. So when it accumulates to a certain point, it collapses, and then it keep accumulating, and then keep accumulating to the top, and then it collapses. So it keep accumulating to some extent before the next fluctuation begin. And at the same time, you can look at how we analyze data. We're splitting, we give the training with the non-stationary data forecasting, and we give in loops. And if it works well, then we go back. And this is the performance optimization. We have to offer the optimization in order to make things to run faster and better. And we also record the time execution. And we also have done several experiments to ensure that the work we have done is accurate and also fast. So then we can then give a computation to see the differences between those, and then it can be applied in other different stocks and in different types of risk analysis. So I would like to talk about the weather visualization, because initially this keynote is in South Korea. So I thought that it's helpful for me, to present something. It's different. So I have done, the weather computation in the last few weeks, but only focus on 3 days in particular. 18, 19, 4 days, 18, 19, 20, 21st of September. So it means that I've taken some special dates and time. And then what I've done is that I collected data of the South Korea, and then we compute them and make them into 11 categories, and every category is in different color, and the color is then mapped to each region of the map. So in the way that I've started with 18th of September this year at about 2:30 p.m. local time, just to see, South Korea. So with the computation, it allows us to see the differences very quickly, just within a matter of 1 second. So if this is the place for Seoul, then you can then look at the temperature is around 23, 24. So within a matter of second, you can then see, Busan is here. There's a cooler, and there is probably around 23 degrees Celsius, slightly cooler. So in a way, with a different time, you can see that maybe Seoul is near this. It's actually even warmer. So when time goes by, it doesn't mean it's actually cooler. It may be due to the fluctuation of temperature. So what are the principles behind? So compared to the previous algorithm I mentioned, this one have 3 workers. It means that each worker is focused on one major task. So there is a map and reduce function. So worker 1 is focused on the map function and to merge all the data accordingly. And the worker 2 is focused on merging the output. So there's output there. So the output of each worker will become the input of the next. So then a reduce input, because in order to get a reduce, we sometimes have to reduce different input in order to get to the final output. So when we then have to perform this, and then in this case, then we have 3 workers to run things in parallel. So we have some very algorithm to show that we can read the data, shuffle the data, store the data, check data, categorize the data, output the data. So then we have 11 category. So when we read the data, we rank them. So then each different rank go a different color, and we check that we map to the right place, and then we visualize it and we optimize it. So optimization is a different process. So there are also 4 different workers So every worker is having a different thing. So one is to get on one, so you get the first done, and you move to the next, and move to the next. So this, you may imagine, these 3 workers are mainly for the MEM function, and then the last one is reduced, and the final outcome. So once you map the right thing, you then get recorded and updated here. So I have a high-profile paper being published. So by you transferring the lessons learned and the principle, we can then analyze temperature distribution of different countries, almost every country in the world. So in this case, you may also see that on 18th of September, on the same day, 7:30, the temperatures still gets there. So it's about 21 to 22 degrees Celsius. So there can be some other ranges that may fluctuate because at the time that the temperature was taken, there can be some other regions that may fall under the boundaries. Yeah, so at the same time, with 9 p.m., you can see the temperature was nearly 24 and above. So it means that you experience a very warm weather on the day, and actually it's even warmer during the evening and the nighttime. So you can see the entire South Korea, they have a different temperatures. So in this case, you can also see that there's a change of temperature when you move to the next day. Let's say on the 19th of September, 7:30 p.m. local time. It means that you have a much cooler weather. Drops to about 16 to 17 degrees Celsius in Seoul, and then at about 10 a.m. Of the day, you have a very cool start. That's around about 16 degrees Celsius. Yeah, 16 plus. So it's like the following day, you had a 20 plus, then all of a sudden drop to 16 to start with. So there can be during the changing weather time in autumn. That's common. Then sometimes you may notice that there are some wide range. Why? Because when the temperature is outside the initial 11 categories, it's just like during the measurement and the time that of analysis, there was a change of the temperature. It all of a sudden became very hot, so that at the time that it can be happening. It means that it's outside the initial measurement temperature. So you can see that this is about 27 degrees Celsius. There can be some area of South Korea became very, very hot on the day, and then it means that in the afternoon time became very warm. And then interestingly, you may notice that the temperature drops to around 17. So it's not like it's just staying warm. It can be just warm for a while, and then the temperature may change over just a matter of 2 to 3 hours. So then we do the analysis for 20th of September. Then we notice that for Seoul, it's around 16 degrees Celsius, 16 plus. So after 4 hours, there's around 17 degrees Celsius. There's not much change. But however, you notice that the change is mainly in the south. The south seems to become warmer, especially this part of Korea, like South Korea is like is above 26 degrees Celsius, like 26, 27. Whereas here at the beginning, you got about around 22 degrees Celsius. So the main difference is in the south, whereas in the middle and north of Korea, doesn't make a huge difference. So it allows us to keep track of changes. So for 21st of September, you can see that the changes in the daytime is like here, you got about 15 degrees Celsius. And then at the same time, you got about 14 to 15 degrees Celsius. So that you can see the difference very quickly. So we can apply the same principle, and we can make the measurement and analysis. We see that the temperature is about 16 degrees Celsius. And then sometimes we can use weather example for other countries. So then we can then see that for Sydney, over a 1 year period of time, the temperature that fluctuates. And in January, it may goes up a lot. because January for them is summer. So in summer, they've experienced a huge temperature fluctuation. But also at the same time, you may notice that there are some red region because it has been very warm, like about above 30, 38, 39, or even above 40. They are in usually indicated by bush for it. So there was a period of time that Australia was under the bushfire, especially last year. It was very serious. So now I've explained 3 examples. I'm going to explain further with social network analysis as a service. So in this case, initially this project was started out of curiosity because I grew up and lived in different countries at different period of time. So I have friends and family. They lived in Taiwan and Singapore, and then of course my family and church members too. So I have a very good friends in Australia and classmates in Singapore. So what happened is that each circle means that each person, and the links indicates that the interaction between you and them, or between your friend's friend and family, surprisingly, it seems like although they are strong circles, but weak link was because a lot of interactions do not take place or have not take place on social network, but actually maybe they give you a phone call, maybe meeting face to face. Whereas my friends in Australia, they rely on social network a lot, so therefore they contact each other very frequently through the social network. And my Singaporean classmates, they sometimes stay in touch with each other. At least they then check up with each other's updates. And therefore, we can apply the social network example for our different areas. So I thought that I'm using my own data as an example. For instance, that was me. There was a period of time I worked in different parts of the UK. I worked in Southampton, London, and Leeds. So that is myself, that through myself, I can get to different groups of people. They are connected together because they are well connected and work together. And the Londoners tend to be more ad hoc. They have a wide range of areas to work on. So they are not always together because they probably have more friends and more projects to work on. That whereas sometimes people in Leeds, they also get together closely. So you may get a similar work relationship if you present them in such a way. But at some time, when we have major topics such as the time that UK has decided to leave EU, so at the time you will get different communities that you don't know each other. Then you have a lot of discussions and a lot of interaction online. So it means that on some major issues, such as even Trump has recovered from COVID-19, so he also allowed to have lots of different strangers and community to talk to each other. So major incident is very helpful for us to capture any trends or any meaningful messages. So of course there are other different services that I will just mention them. So education as a service, for instance, it allows postgraduate students to learn different statistical analysis, so they can then see around data and compute them at the same time and understand the meaning of this statistical analysis. We can use that for consulting, because for consulting, it helps different stakeholders to know between different layers, how they're related to the infrastructure as a service, platform as a service, software as a service, and business model that can connect very well to each other. And then we can apply them, as a special case study for cloud computing business framework. They work together with different type of technologies and to resolve the problems. So at the same time, we can use and apply data science and the AI together. So this is the 2016 GDP with different European countries in place. And then you can see that in Europe, Germany, UK, and France are ranked for the first 3. So if the UK will leave the EU in the following year, it's going to have a huge impact to the European community. So you can then see this. But actually, data analytics will also give us more questions to think about. How can we do things better? How can we manage our future perspective together? So I would like to sum up the summary contribution In my talk, I have provided a better, faster, easier to use services with different examples, and there are real cases with services and real adoption, and then to interplay between big data analytics and AI, because a lot of this can be done together, and we can then know if they are doing together, it can help us to resolve a lot of issues. And then of course, we can have a successful proof of concept, delivery and services to help the people and organization in use. And then we can then use all the best practices, all the different approaches and all the software framework and the adoption framework together so that we can then offer consulting as a service. Because a lot of these technologies, they need to work together well, especially with the AI, big data analytics, to get us to understand the meanings behind so that we can then work on different disciplines. Of course, with the data fusion and integration of different services, it will help us massively. And then our work can be very effective for different disciplines. Of course, there are a lot of publication awards and excellent R&D outputs. So if you have a question, please email me with this Gmail or the other one. And I work with different journals for special issues. And I'm well connected. I'm one of the highly cited and leading researcher in data science, AI, IoT, and similar technologies. So if you have any question, please let me know. And I really appreciate your time to listen, and I wish you all the best. Hopefully we may have the opportunity to meet and discuss in person after the impact of COVID-19. Thank you so much. Have a good time and all the best. Thank you. Yeah, bye.